So if you look at this diagram, you can understand that if it was a good model, fitted versus actual plot should be around this line connecting the origin, which is this point, to this point, right? But you can see this is kind of a convex and away from this line, hence this is not a very good model. So we need to modify this. I did a bit of feature engineering and found out that if we modify GDP, GDP per capita, Gini and density using these powers 1/4, 1/4, half and half, we will have a good model, a rather better model. So we will be using these features now, modified features. So using the modified features, let's have a basic model. Gives an adjusted R square of 0.82, which is a jump from 0.5, which is a pretty good thing. But there's a problem that again only GDP per capita input, or rather the modified GDP per capita, is significant. Rest of the coefficients not significant. So again we will do the same thing. We will discard them sequentially and find out which model is better. When we use modified GDP per capita and modified Gini index or Gini coefficient, we have a much better model. Having an adjusted R square of 0.82, we can find out the accuracy using the MAPE numbers, which is 91.893. It's an improvement from 85%. Now we can also plot the actual versus fitted. We have somewhat better plot because now you can understand that it is some way around the line which we want it to be as desired. Still, there are a lot of points which are away from the line, making it appear a bit convex. Plus, the bigger issue is that a lot of the fitted values, the HDI numbers are greater than 1, which is not permissible because HDI ranges from 0 to 1. So definitely this model is also not good for predicting or explaining HDI based on GDP per capita. So we will have to modify the model further. So the moment you have this kind of a situation that the output or the dependent variable is from 0 to 1, we can straight away use a